Look at your phone case. You see that little grid pattern on it? Most people think that's just a design thing, something to make it look sporty or feel better in the hand. But that pattern has nothing to do with design. It's the same shape that engineers used to build the fastest warplanes in World War II. The same shape NASA used to protect astronauts flying to the moon, and the same shape that bees figured out around 50 million years before any human was even born. And somehow, it ended up on a phone case you bought for $14 on Amazon. Here's the thing. There's a reason this shape keeps showing up everywhere. From beehives, to bombers, to your back pocket, and once you know the reason, you'll never look at your phone case the same way again. Let's start with bees, because bees, as it turns out, are better engineers than most humans. For as long as bees have existed, and that's around 50 million years, they have built their hives out of tiny six-sided cells. Not circles, not squares, 6 sides every single time, without exception. And for a long time, people just thought, well, that's a bee thing. Cute. But around the year 320 AD, a Greek mathematician called Pappus of Alexandria looked at a honeycomb and asked a question nobody had really asked before. Why hexagons specifically? Why not any other shape? And what he worked out was this. If you want to divide a flat surface into equal cells, think tiles on a floor, the hexagon uses less material to cover more space than any other shape. It's the most efficient option, mathematically possible. Bees weren't doing it to look cool. They were doing it because it meant they could store the most honey. Using the least wax, 50 million years of trial and error, and they'd landed on the perfect answer. But here's the part that really matters. The hexagon doesn't just store things efficiently. It's also incredibly strong. When something hits a hexagonal grid, a force, a weight, an impact, the hit doesn't stay in one spot. It spreads outward through the cells, like ripples in water. The whole structure shares the load. Nothing breaks, because nothing takes the full force alone. Bees had this figured out 50 million years ago. It took humans a world war to catch up. It's 1941. Britain is in the middle of World War II, and an aircraft designer named Geoffrey de Havilland has a problem. He needs to build a bomber that's fast enough to outrun enemy fighter planes. But there's a shortage of aluminium. The war has been eating through it. He can't build solid metal panels for the whole aircraft. It would be too heavy anyway. So his engineers try something different. They build panels with a hollow core, and the core is made of thin material, folded into the shape of a honeycomb. It works better than anyone expected. The panels are light, but when something hits them, shrapnel, wind pressure, anything, the force spreads across hundreds of tiny cells and disappears. Nothing collapses. The plane they build is called the de Havilland Mosquito. It becomes one of the fastest aircraft of the entire war. It flies without guns on some missions, because at top speed, enemy fighters literally cannot catch it. All because someone looked at how bees build their walls and thought, what if we did that? And then NASA came along. When engineers started designing the rockets that would carry people to the moon, they had an even harder problem. The spacecraft had to survive being blasted off the Earth, float through the freezing vacuum of space, and then slam back into the atmosphere at 25,000 miles per hour without burning up or falling apart. They needed something incredibly light, but strong enough to handle forces most materials would crumble under. They used honeycomb panels. The same basic idea Geoffrey de Havilland's team had used to build a warplane 20 years earlier. The same idea bees had been using for 50 million years. The Apollo capsule, the heat shield, the walls of the lunar module, all of it reinforced by a 6-sided grid. So, bees, then a warplane, then the moon. You already know where this is going. In 2007, Apple released the first iPhone, and it was stunning. One big sheet of glass, nothing else. Also, it shattered if you looked at it wrong. Suddenly, millions of people were walking around with a fragile glass rectangle in their pocket, dropping it on pavements, on bathroom tiles, on the edge of desks, and an entire industry appeared almost overnight to protect it. The problem case designers had was this: how do you stop a phone shattering on impact without making the case so thick and bulky that you've basically got a brick in your pocket? And the answer, which engineers had already known for 60 years, was the honeycomb structure. That mesh pattern you see on your phone case, whether it's a full grid, a partial pattern, or just a textured surface, is doing exactly what it did on a World War II bomber and a moon rocket. When your phone hits the floor, the force doesn't smash straight into the glass. It spreads across all those little cells and disappears. The same principle that kept a mosquito in one piece over occupied Europe is now keeping your screen in one piece. On the way down to a coffee shop floor, your phone case probably cost you somewhere between $10 and $30. But what you've been carrying around in your pocket every day, that little grid on the back, is a shape that bees evolved over 50 million years, that a Greek mathematician wrote about in 320 AD, that a World War II aircraft designer used to build the fastest plane of his generation, that NASA trusted with the lives of the 12 human beings who walked on the moon. It's the same answer every single time, because it's always been the right one. So, what other everyday object do you think is hiding a secret like this? Tell me in the comments. The most interesting one becomes our next video.